questions 4, 5, and 6 referred to the basic graphs, straight line, hyperbola, parabola, and then the one that's a little bit more spicy, the exponential. Let's start with question 4 by looking at the question. Question 4 says, given fx equals a over x minus p plus q. Now you can see there's been some shift from what we are used to normally in grade 10. When we start in grade 10, the hyperbola in its basic form is given to us as f of x, which also represents y, so that's exactly the same. And that is equal to a over x. Now I want you to note something very important which underlies the idea of an asymptote. I've asked a learner once, what do you understand with the word asymptote? And I liked the answer that I got. Never, never. That means I can't ever go and do that which the asymptote says is the answer. Now let's see in this case go and find out what the asymptote is saying. For fx to be defined, we learn this from grade 8 onwards, that in mathematics, whatever we do, whether we work with a function, an equation, it is defined only if the denominator is never equal to 0. Now, if you just look back at your given equation, y equals a over x. In that case, x becomes the denominator. Therefore, x itself can never be 0. If you should cross multiply and move x across, y down, then y becomes the denominator. Hence, y can't be 0. And therefore, the asymptotes of that simple hyperbola will now be x equals 0, y equals 0. That means it can't ever be that. And the asymptotes will therefore be the y and x axes as we know them. Now let's just see how this affects the graph that we have just referred to. From the given graph, fx equals a over x minus p plus q. If you look at the given graph, you can see instead of the hyperbola, which is normally, if the a value, if we have y equals 4 over x, if that a value is a positive, then the hyperbola will be like a parabola turned on its side. And it will be placed in the first and the third quadrants. Why? Because in the first quadrant, both your x and your y coordinate, so any point that you have on that branch, has x as positive, y as positive, and when I multiply that, the product, because if I say y is, then it also means x times y is. Therefore, that answer needs to be positive. It will happen in the first or in the third, where x and y are both negative, and as you know, negative times a negative is also positive. Hence, you have those branches in the first and third whenever the a value for that hyperbola is a positive one. So let's just go to the question that was given to you. They've given you the sketch in this case, and they said the equation is represented by fx equals that. So what is actually implied there? That the x minus p is a shift of x equal to p along the x-axis, and the q is a shift either up or down, depending on the value of q. If it's positive, it's up. Negative, it's down. That happens along the y-axis. So let's quickly look at the question again. You are given fx, but they are not giving you the values of p and q, but importantly, they are giving you the asymptotes. So hulle gee vir jou die asymptote. Die een asymptoot is by x gelyk aan 2, want die punt A is die punt waar hierdie gebroke lyne, those dotted lines meet at the point A, so the x is the first coordinate, so x is 2, A is 3, en die maklike vraag, write down the equations of the asymptotes. They were quite simple. If I wrote them down, the equations of the asymptotes, x equals 2, y equals 3. But that immediately tells me that I can write the minus p as a minus 2 and the plus q as a 3. The second question says, go and determine, so 4.2 sê, bepaal die vergelyking van daai hyperbool wat genaamd is f. Nou ons het nou al reeds, die volgende. We have y equals a, so the unknown at the moment is a. Right, but we've got x minus 2 and we've got the plus 3. And by now you know that if you need to find one letter or variable that is not known in an equation, the easiest way to go is to substitute a given point. And in this case, you will notice that you've been given the point on the x-axis, the x-intercept 1, 0. Let's just quickly check. That point was given to you on the hyperbola, and hence you can replace 1, 0, the x value and the y value. If y is 0, the x value is 1, so that becomes 1 minus 2, which is minus 1, plus the 3, a from there, because that's now going to give me negative a, plus the 3 says a itself will be positive. And notice, we expected a to be positive, because we said right at the beginning, if we work, let's just go back to something that we've mentioned before. We said if we work in the first and third quadrants, the a value is going to be a positive value. The only thing that is happening here is you've taken the same graph with a positive and you've shifted it along the x-axis and along the y-axis to produce what we have here. A shift to x equals 2 and up y equals 3. So from that, by finding a's value, we now have the equation of f. You were also asked to go and get the coordinates of point D. Now D, as you can see, is the y-intercept of your hyperbola. Now let's quickly, to save time, the coordinates of the point D, as I've mentioned, requires the y-intercept, but at the y-intercept x is 0. So if x becomes 0 in the equation that we have, 0 minus 2 just gives me a negative 2 at the bottom, so I have negative 1.5 plus 3, which gives me a positive 1.5. Remember, you were asked for the coordinates, so don't go and throw marks away. If you ask for the coordinates, it means that you need to indicate both x and y. Hence, you are finding in this case that your answer is 0 with 1.5. Now, I would just like to remind you, go and check your answer. Let's say you got the y value to be negative, but D is a point above the x-axis. X-axis is below D. Therefore, the y-intercept had to be positive. And yes, it did make sense that that was 1.5 and below the y value of 3, which was an asymptote. Right. Let's just quickly look at question 4.4. In 4.4, they are asking you to write down an equation of G. All right, they are telling you that there's an equation called G, which is the straight line joining A to D. So point D and point A are being joined via a straight line. Okay, let's just notice what happens if we do that a little bit clearer. If I take in 4.4 the hyperbola, which is meeting the y-axis at D, and it runs through the point the point A first, and then I've introduced a point E, which we are going to get to a bit later. But for the moment, I want you to concentrate on the point A and the point D. Those are the two given points. For any line, we are now quite sure that y equals mx plus c. But you've already had the line and the hyperbola having the same y-intercept. The y-intercept at D refers to both the hyperbola at point D and also the line running through D. Hence, the y-intercept was straightforward 3/2. By substituting any other point, which in this case was the point A, because you've already used point D to get that value at the end. So another point, point A, you're replacing x and you're replacing y, and what do you find? You find m equals 3/4. For those of us who didn't see that, you could also have used the gradient formula, which, by the way, is written in on the formula sheet. That is the difference in the y coordinates over the difference in the x coordinates. That would also have given you 3/4. Just to get to the last question, 4.5. Many learners found this quite tricky. Write down the coordinates of the other point, right of intersection between F and G. Now remember, we said that G is the line, F represented the two branches of the hyperbola, and you can obviously see that D was the one point of intersection, which you already had, and now I've called that point, as I said to you a moment ago, the point E. Since we're going to find that other point, I'm for the moment going to call it X and Y. Now look at something interesting here. The symmetry, not only because of the axis that we have there, the asymptotes running through x equals 2 and y equals 3. Right. If we look at that, we will notice that the hyperbola is evenly spaced, the two branches, from the point A, and hence the movement right along the x-axis, let's just indicate that in a different color, that movement along the x-axis compared with, if I should represent this as a triangle, that triangle and that triangle gives me the same x movement for both of them too. Right, and for y, I am moving, if I look at my y movement, I'm going from 1.5 to 3, so that would be 1.5. So what would you do? Let's just quickly see if you have to go and work that out via symmetry. If I had to do that via symmetry, over here I'm calling the x just a A, same value A, and the B represents y. I'm saying that, as we already mentioned, the A is 2, the movement along the x-axis, the movement along the y-axis, which we're calling B, is 1.5. And if we go and indicate that from what we had earlier from point A to point E, you're adding A to 2, which is then 2 plus 2, 4. From point A, the y coordinate was 3 plus 1.5, 4.5, and you could just by reasoning things out logically, using symmetry, get that result. But for those of us who do things the conventional way, we stick to the safe method. These two equations were given to us, or we worked them out along the way. The hyperbola and the line. And those two must be equal to each other. So if they are equal, then it means that I can equate them in the equation. The awkward part, which many of us struggle with, is that there's denominators 4, 2, x minus 2, of which the lowest common denominator will be 4 times x minus 2. What would you do in that case? Multiply each of these terms by that lowest common denominator there, and there, and let's see what happens. In doing that, your denominators disappear, and you end with a nice quadratic equation. Many of us panic when we get only 2 terms in the quadratic. In this case, it makes it easy because we can take out a common factor, get that x value as 0, and didn't we expect that? Why did we expect that? Let's just go back. We said that one of the points of intersection was a D. Therefore, at D, the x value was 0. So we expected this result. If we didn't get it in our factorization, we had to go back. Check. There is the other one, x equals 4. By plugging that in, we would get the y value of 4.5. Look difficult for many people. As you can see, not really that hard if we keep our heads.